Okay, so what we'll see today is chapter 2, which is PyTorch workflow fundamentals. The previous chapter discussed about the PyTorch fundamentals, where we saw tensors, how we deal with tensor and every other things. So today we'll be able to see the workflow, how you can train a model. And we'll start with a toy examples on training a regression line, linear regression, just to get started. And we will, bootstrap from there to scale. Now, when we, in deep learning, what we are doing basically is, we start with data and train the model from the beginning to end. At the end of the day, we have our data and you have the trained model finally. Now, what is happening is that you have a source data, and this data can be anything, whether image, text, video, audio. You convert them to tensors, as we already saw, right? Data is converted into tensors, and now, you feed them, you do the training. So maybe you have multiple GPUs here. This is called distributed training. And now you do the training on multiple GPUs. And now after everything finished, then you have a train model. So if you want to deploy it, you deploy it. So this is something the cover. So like, how can you, the first thing is get data ready. That is this one. What does that mean to get data ready? It means to change it to tensors. Now, if your data is image, how can you change image to tensor? If your data is text, how can you change that text to tensors? If your data is audio, how can you change audio? So there are all these ways, like image, text, video, they have different ways of changing them to tensors. So we will see them. So now turn them into tensor and now build or pick a pre-trained model. So what we mean by training, like, you finish this one. What we mean by the training, the next thing is to pick or build, pick a pre-trained model. So the next thing is to take which kind of model you want to train, like RNN, CNN, or transformer based, or you want to use pre-trained model that we use now. That is it. And now, when you pick the pre-trained model or you build the model that you want, you train it, that is pick the model, that is training, and you evaluate. So while this building and picking the pre-trained model, you build a training loop, to pick a loss function and optimizers. We'll be able to see all these, steps along the way. Yeah. Any question? So, what we'll be seeing, like training using PyTorch from end to end is something like this. Get your data ready. You need to pick a model, or build a model. What we mean by build a model, you build the model yourself. What we mean by pick a pre-trained model, there are now existing models that you don't need to build a model. You just pick them. They are pre-trained. They are already trained. Only you need to fine tune them. Now you feed the model. When you take the model, feed the model means train the model, and now evaluate it. To evaluate it means to fine tune. To calibrate it to see how the model performance works through. And you can also improve through experimentation. So maybe when you feed the model doesn't perform well, you can improve, you can reiterate, because deep learning and machine learning, it just involves experimentation. It doesn't mean like when you train a model at the first go, it performs poorly, you just say, okay, it doesn't work. No, building a model, this is some way called iterative process. You need to change this, update this, change this parameter, change this parameter and see what works, and now finally, after you finish everything, you can now save the models and load the model in some other days that you want to do. So this is the pipeline we'll be able to see in this workflow. Now, in a nutshell, this is what we're going to do. Get the data ready, building the model, fitting the model, making prediction, saving the model, and putting it all together here. Yeah. So that's the thing that we gonna look up today. We'll do this one, we'll do this one, and we'll do this one. Any question? Okay, so here he just itemize what we are going to do: prepare data, build model, fitting the model, making prediction. This is the same thing here. Now before we go on, I want to remind us some stuff because, these PyTorch involve a lot of things that maybe if your Python is rusty, you need to come back and remind yourself like a lot of basic concept such as Python module, Python class. So here I just want to, revise us, like for us to remember this stuff so that when we go down, you will not be just seeing something, for the first time. I know you know this, but some of us, if they, forgot about Python module and class, I will revisit them. So now what is Python module? Because the reason why I want to revise this is what we'll be seeing later on, or we'll be dealing with what is called classes and uploading classes and every other thing, right? So that's what we want to revise this. So what is Python module? So a Python module is just, a file, just a file containing definition or statement that is called Python module. Now, for example, here I just create a file. Can you see that I save it my module.py, and inside this Python module, I just have a function called add. I have a function called subtract. I have a function called multiply, and I have a function called divide. And now you can see I just put them inside .py file. This .py files is now called a module. Yes, so let's look at how we can use this one. So you can see the name of the file is called mymodule.py, right? Mymodule.py. Now inside it, I have many functions to do addition and stuff like that. Now, the reason why, you create module is like you don't want to, have multiple, code in different places in the same file, so you can abstract that. So now in this case, I can import my module and now call this add function. What this add function does, you can see it add two values inside here. So now I can just call it here, import. So we use this keyword import to import the content in the module. So here I can say import module. Now I need to use this name that I import module dot add. So when I do this, it will automatically add this, stuff. So yeah, it will add this stuff. So we can see this is what it means. Now here you can see we import the module, automatically import module, but there are some other ways like, from module import add. You can see here from module import add, we automatically, import add functions. So we don't need to use this. So I can just refer to add directly. So when I run add, it will give me the something. But here, because I import module and inside module, I have a lot of function, a lot of things. I just import the module. So for you to refer to any specific item inside, whether add, subtract, you need to, use the name of the module and the functions. But here from my module import, I import the add already. Sometimes you may rename the module name. Sometimes you may see import module as MM. So because here I type my module is very lengthy, I can just shorten it, import module as MM. So it's the same as this one, but I need to just type MM, then I call this add here. So, this is something that I just want to remind us what module is, and we'll see a lot of this stuff along the way. I will also remind, we'll recall classes and how we deal with classes in a bit. Any question before we move on? Yes.
So module is different from package.
Yeah, so that's a good question. So who can answer this question? What is module? What is the difference between module and package?
I think they are similar. Like in Java, we are using package, but in Python, I think they are similar. It's just a nomenclature.
Okay, any other one that can attempt?
Yes, in Java, what we call package is when we have similar classes, we pack them into a package. That is it.
Okay, let's look at it. Package versus module. So package is just collections of modules. Do you understand? Module is a package is like a directory that holds sub packages. Can you see that? And modules. So like, look, we can say that like a package is the bigger subset. So let me see something like the image. Okay. Yeah. So you can see something like this. Inside this, there are some, can you see we have laws, we have training loop, we have data set.py. All these one are, modules. And now they are packed everything inside my module, which is a packet. Let's look at what this guy, a packet hold the init, yeah, something like this. A packet also called the init method. This module does not apply to running time. A module is file containing Python code at runtime for specific user operation. So we can say like, you know, a packet is some kind of, you know, a wider stuff, and it contains the init method. Yes. And we can see here where we have this module, it does not have any init method. It just like, you know, yeah, the contents. And for more things, we can Google and, you know, yeah. So, okay, so that's module. So let's move on. So we are going to get touch NS. Oh, okay. So we gonna do training module. We said we gonna follow this, you know, workflow to get our data ready, build a model, fit the model, evaluate the model, improve the model through environment, and save. Now we're gonna go through all those things, but what we need basically to do that, we need some kind of you know, modules from Touch. So you can see here I say import Touch, from Touch import NN. So you can see here we have one, you know, module in packet in Touch NN, import it. Now here we have this. We'll come to this. I just you know, import this, guys. One thing I like doing, there is one package called watermark in Python. When we have watermarks, when you load something here, everything you load, when you call this guy, it will just show you the version of everyone. Like here, you can see when I want to see the version of my Touch, I use this version Touch. But what about if I want to find the version of Matplotlib, the version of everything that I load? Using this, a single line command can show you the, you know, version of everything that you have in your yeah. So it's a packet called watermark. You can Google it. You can see.
So how about iVersions? Is it the same for any other OS?
What do you mean by iVersion?
Watermark iVersions.
iVersions.
Yeah, iVersion. Watermark iVersions.
But I don't know it. What is it? Watermark.
Second cell. No, second cell.
Here, this one.
No, you mean second cell. Second cell, yeah.
This one.
Yeah,
okay.
yeah.
Yeah. So this is, you know, how to get the versions of everything. So here I load it. I load the watermark, because you can see I haven't used import watermark anything. I just use load watermark. So without this cannot give me the, you know, versions. Let me see. Oh, it gives the version as well. Because I already loaded, you know, if I restart.
Okay, I understand.
So, you know, this watermark, you know, it shows you the version. Yep. This is just something that I quite use, like, you know, trying to find the version of everything. So let's go on. What we said we're gonna do. So the first thing we said, if you want to train a model, get your data ready, right? So we want to get our data ready, but however, we want to use like a toy example. It's not a full-fledged example. It's just something that we want to try small, then we can scale. So that's what it is. So data preparing and loading. So is it my screen? Can you see it vividly?
Yes.
Okay.
Yes. Yeah.
Okay. So we already said that when you are doing machine learning or deep learning, data is anything, audio, video, whatsoever. But the first thing you have your data is just to turn it into, you know, some kind of, tensors. So here he said machine learning is a game of two parts. That is it. Machine learning or deep learning is a game of two parts. You know, the first thing, Noor, I can't see the screen. Okay. Can you see the screen, everyone here?
Yes.
Yes.
Noor cannot see the screen. Maybe Noor, you can reconnect again.
Okay, thank you, Doctor.
Yeah, so you say like deep learning or whatsoever machine learning is a game of two things. The first thing is turn your data into numbers, then build a model to learn patterns from these numbers. That's just the ways machine learning works. So you can see here we have our data. This is input, which is, you know, sound, text, image, or document. Now you turn them into numbers. This is numerical encoding and transfer. And now just use your model. So this is our model that learn. This model will learn representation because this one, maybe if it is, text in English and you want to translate it to German, when you pass it to the model, then this model will be able to learn the representation and translate it to, Korea or whatsoever. Sounds crazy, right? But that's how these models works. It's something complicated here inside this. That's why they said, new deep learning or neural network, deep learning is, black box model, meaning like it's not explainable because we don't know what is happening here. You just pass, your numerical representation inside this black box, and through this material multiplication whatsoever you are doing, multiply this by this, add by this, and it turns out that it can be able to understand or pick pattern and now give you the resultant one. So that's basically what happened. Okay, so now let's assume we want to create a data. We don't have a data yet, so let's create a synthetic data. When I said synthetic data, I mean like, what do we mean by synthetic data in Hausa? Or fake data, right?
Okay,
Yeah, fake data, right? So let's create a synthetic data that we're gonna use an example here to train, like, to build a neural network. So we already know, like, if we want to have our data to train a machine learning, we need to have this future matrix, and now we have a vector, right? That is, this is the futures that we want to train. This is what we want to predict. So what we want to do is to, create a data based on linear regression. We already know linear regression. Linear regression is y equals to mx plus c, y equals to mx plus b, right? So what this is telling us, we are building something small from this, just to show the, the idea, then we can scale. So what we are saying here is, if you are given this y equals to mx plus c, it means we already know b is called bias, and x is your future. What is this? Can you see x? And now here y. Here is your target. That is what we want to do. So we want to build, given x, we don't know what the x is. So let me use this to be my x. So I want to create this x here, x here. So I'm going to use arrange. We already know what arrange means. What is arrange? Who can tell us what arrange does?
Will give us a range of,
range of numbers, right? So it you can see what arrange does is it will give us a range of numbers, and the range of numbers start from 0 and end on 1, and with steps of 0.02. Step means if it starts from 0.02, the next one will be 0.04, the next one will be 0.08. That's what this does. If you look at it here, the arrange, that's how arrange works. So this is arrange, start, end, and step. Can you see that? That's how arrange function works. Start, end, step. So this is start, end, and step. Now I want to build a future matrix, and because we don't have data, so let me show it here. So let's look at what is x, so you can see it. So you can see it start from 0, 0.02, 0.04, and you see up to 0. Something like that. But I want to build a future like this, so I can unsqueeze it to add one dimension. Remember, we do unsqueezing. So when I unsqueeze this guy, can you see it now? A single feature, because it's single x. I have only one feature. Can you see here? I have 1, 2, 3, 4, 5. But here you can see I have a one feature. So you remember what we did was unsqueeze yesterday. Do we remember unsqueeze?
yes.
Yeah. So yeah. So that's why I was saying, like, you need to practice, like, to go through what we did yesterday. If not, because all we did, those fundamentals, you will just be seeing them. So if you already see them, you will not ask like, oh, why do we need this? Because you already get the idea. So here I just create, like, a single feature. Now, what about this target? Let's build the target. So you can see here we have 50 by 1, right? But first, before we unsqueeze it, What is the size? Oh, no, let me run this guy. Yeah, you can see it 50, right? So that's basically what I did. I create now a feature. So let me create a fake, synthetic target as well. So how can I create synthetic target? Remember, y is equals to mx plus b. If I have like b and m, these are constant. They are constant. So we can, use them. I can assign them. These are weight. This is bias. Remember. So when we are training deep learning, what we are learning, basically, we are learning these two things, weight and bias. What you need to do is first, you initialize them with random numbers. You initialize this weight and bias with random numbers. And now you learn them. You iterate changing this weight and bias by learning, okay, if it is not good, you change them. So here we can run this guy because I already have X, which is this. And now I have weight, which is this. I have bias. Now, where I run this, you can see this is it. So therefore, this is my X. I have my X, which is this, which is one feature. I have my target here. So here, remember, I'm just, building a synthetic data that we're going to use to train a model. So this means that now we have our data that we can use to train a model. Yeah. Any question before we move on? You don't need this step when we have our data. It just now we create a simple data set. We don't want to do some kind of complex stuff. Yes.
Doctor, for on screen that why can't we use flatten with X flatten instead of on squeeze?
Flatten like this?
Yeah.
Look at it. Flatten, remember, if you have a tensor, multiple, you want to move into a single.
Since it is already a single, we have.
Yes, exactly.
It
Yes.
is a single. If they say there are two or more features.
Yes, exactly. Exactly. Yeah. So that's it. So yeah, so we already know that if we have existing data, before we train a model, we need to train test split, right? We already know this in our machine learning class. And here they, just say that, okay, in training data, we sometimes use 60-80 or 10-20 or 10-20 for test. For training, we use 60 and 80. For validation, sometimes we use 10-20, often but not. So this is just telling us, what we already know. So now let's split our data set. We already have X, we have already Y, right? And now let's test size 0.2, that is test size is 20%. And a training size. So who can tell us now if test size is 0.2, what is training size now?
80.
Yes, so our training size is now 80. So let's divide this. So when we run this, guys, now we have this. So we can see now we have our training size. So training test is 40, Y train is 40, X test is 10, and so we have everything to train a model, right? We have everything to train a model now. Now, before we train a model, because this is a straight line equation, we can see like we have this, so there is a relationship between Y and X. So given all this, we find that. Let's build a function that given the training size, training data is X train that we just divide here. Train levels, that is the target, is Y train, right? Because this is Y train. Given any X, it maps to Y train, we know. Test data, X test data, and Y level is this. We have prediction here. So this function basically, we can see we create a figure here, and now we use scatter. Given X train, map the S level, right? And here given test data, map the test level, right? So let's look at what this prediction, because we have not make any prediction, we have not trained a model. This is not anything, but let's see how we can plot this stuff. This is not gonna work here. We will come back to it later. So let's run this. When we run this guy, let's run a prediction. So you can see here we run this model, or not a model, we run this data that we created. What we can see here is that the training data, the blue is training and the test is what? Red. Is it red color or what? I'm not sure what color it is.
Green, right?
Green? Okay. Sometimes I don't know colors.
It is great.
Okay, so you can see what this is telling us, because this Y, we obtain this Y from the same here. It means there is a relationship between Y and X, right? Y and X, because we use this, right? So you can see like here, these are the point. This training data is blue. All these are blue. These are testing data. Testing data is green. Testing data is green. Now the M is this. We want to train a model that given a training data, can it try to map it this way? Can it try to map it like this? Do you understand? Here we have not trained a model because we just plot the data. We already know the data is like this already. This is our data set. This is the training data, which is yellow, blue, testing data, which is green. Now, what we want to do now is this. Given a model training data, we'll test the model using test data to see if the model will be able to give exact location of this test data, because we'll train the model without test data. We'll train the model only with blue. We'll train the model only with blue. And now we'll give it the test data without the level to try to see whether it can predict the correct location of these ones. Do we understand the problem?
Yes.
Yes.
Do we understand the problem?
Yeah.
Okay.
Yes,
So,
yes,
yeah.
doctor.
Yeah, so this is what we are going to do. Like we have a training data and we have a test data, and we'll train the model with the training data, and now to see if the model can now be able to make a good prediction on test data. So we'll see that in a bit. Now, as I already says, you know, we are going to encounter a lot of things. We have revised what module is in Python. Now let's revise a very, very important concept that we will be able to see, you know, in PyTorch, which is classes. If we don't, if our classes concept is rusty, then we will know where anywhere with PyTorch. Now, so what are classes? You know, in Python using OOP, classes allow us to do some kind of abstraction without repetition, right? How do you, you know, I know all of us, maybe we are familiar with classes, but let's just recap that. To create a class in Python, we use the keyword class and name the class here and put this semicolon. This, we usually use capital letter to start with it. Yeah. Now, this is a class called dog class, but we also have a method, init method that initialize any object in the class. So we have init method, double underscore here, you can see it. Then this method, the init method, each method in the class must start with self. This is just it, just, you know, self. Now we have two, you know, variable, name and age. That is the name of the dog and the age of the dog. Now, to access the name, you need to use this pattern, like to call this self.name to give the name and self.age to give the age. This is how we define a class in Python. This init method, each and every class is a special method, which is called when an object is created from that class. I don't know if there is any question. Do you have any question regarding creating class, simple class like this? Each class, a method, we might have init method, and you know, we start with self, and you know, this argument. If it doesn't have any argument, any variable, you can just have self like this. But we know a dog, we want to have like its properties. It has a name, it has an age. So that's why we have this. Now, when we have a class like this called dog, we can create an object from this dog. Now, how can you create an object? So for you to create an object, you can just say, for example, my dog or her dog equals to, what is the name of the class? Dog. You just name the class dog, and now give the two, what the dog class expect by default is name and age. And the name is, you know, string. We can say Tash, and the age is 3, for example. So we can have this. So now here we create an object called her dog. And with this object, we can access the message and the name, I mean, some properties. So we can see like one of the property of this object, we can see here. We can see here, it tells us this is of type dog, is of type dog because it's of class dog. Now we want to say maybe we want to access some of the variable here. What we need to do since we create an object. So this her dog is now our object. Her dog is an object of class dog. It's an object of class dog. Now, so we can take this guy, you know, her dog. If I want to access anything, I can say we use dot notation, dot name. What is the name of this dog? You can see it tells us it's called taxi. We can say what is the age, dot age. What's the name of this dog? It is called, it says it's 3. So meaning we use the name of the class to create an object, right? And we use dot notation to access the variable or stuff inside it. That's, class. Any question? Any question? Okay, so, now we saw that we can have init method inside a class. You can have what we call, class attribute that same value for any object in the class. So we can have a variable here. Immediately after the class definition, we can see like a species, Canis familiaris, a species of the dog. So let's assume we have, we added a class attribute for this class called species. We can, create an object, my dog, the same way. And now I can still use dot notation to access the class attribute, which is species. So when you can see, it tells me what kind of species is, right? I can create another object, his dog. You can see that, and we say which species is this. So we can see we can create many other objects. They can have the same this one. Any question?
Yes, I have a question.
Mm-hmm.
Yes, can we create multiple constructors in Python, like what we do in Java? The init method is serve as the constructor in Python.
Yeah.
Can we create more init methods?
Yeah. So yeah. So here, what Valerie is saying, this init method is called constructor in Python. It's called constructor in some way. So if you don't know what constructor is, it's called constructor. So he's asking a question: can we have multiple constructor init method? I'm not sure anyway. To have init for one class, multiple init. Maybe we can check, but I don't have the right answer on top of my head. I'm not sure. Anyone with can attempt to answer Falalu question? Anyone? Okay, maybe Falalu we can find out later. So this is a constructor we have for this class, and now we can have instance method. So we can have functions of this class. We can have multiple functions. So here is a constructor init method that each class must have at least if you want to instantiate the object of the class, you must have a constructor, at least one, to initiate it. But you can have instance method for this class. So here we can see we can have a method. So you can see this is def, which is function. So any function inside a class is called a method. Any function inside a class is called a method. So these are called method. Remember, outside the class, we call this function, right? Here is a method. So here we can see, here we have def, description, self. Remember, I told you, even if it does not have any argument, you must have the self. Now we said here, return self.name. So one good thing is any, variable that is declared in a class with self dot will be accessible inside any other method inside the class. So here we can see we access self.name, which is here, we access it, self.age, we access it inside this method. Here we have a function called method called speak, and it has an argument called sound. And we can see we asset this sub.name from this here, and now we have this. So these two are called instant method. So meaning now we can summarize saying that a class may have init method to instantiate object with that. And now we can have other properties which are called method that can be used by that class. So you can see here, this give init method give properties of the dog, which like the age, the name, but this one, gives some kind of other more information. For this one, like it's a method which is a verb that the dog speaks, bark or something like that. And this one also normally like the method are some kind of verb action stuff that do. So let's look at how we can do this. So here you can see I create a dog called Miles. The name of the dog is called Miles. And, I can instantiate it because if you want to instantiate a class, which is this, and now I can, call the method. So for us to call a method, remember, if we want to call a property, we just call .name, right? So if I call the name, it give me. If I want to asset the age, a property, I can just say the age. But if you want to asset a method inside class, you need to put this bracket, because this is a method, right? So when I asset this guy, it's happening. Yeah, we can see here, file.name, sub.name is, the name we give, which is Miles, is 4 years. Can you see that? So you can see this is how to access a method inside for a class. Yeah, any question? This is just a recap. I'm going faster because this is something not discussed in the material, but just to recap, some concept that we'll see. Any question? Okay, so there is something also called docstring. You will be able to see it. So a docstring, if you have a function, we already know in Python, if you have a function, you can have something like this called docstring, which just like comment that explain what the function is doing. So here this from a complex number explain what the function does, and the keyword of the the function, we have real, and we have another keyword image, so this is docstring. So don't be confused when we are working, you see something like it. It just explains some information about the function. So we can see this is a function. So here you can see I have another, you can see my function, my class. So our class can have a docstring. So here you can see I have a docstring. It takes the name of it. It takes the name and age of a dog. And what are the parameters? The name, which is string, name of the dog, age, integer, which is the age of the dog. And now what it returns. So it returns some of these. Just give me a minute, please. Okay, so this is what we call docstring. And now why this docstring is important, I will show us an example. So for example here, I have the class dog. I can call something like this, dog. Okay, I have it later on. I will show us later. I have it already. So let me use this so we can see here the same thing. What I did here is just to add this docstring, different from the previous one. Okay, so this is okay. Right. Okay. Let's see in inheritance, which is what we will be seeing in the PyTorch. This is something that is really important because all those classes, they are inheriting classes. So let's look at what is inheritance. So inheritance in Python is like you can have what you call a base class or parent class that it can inherit something from the, a child can inherit from the parent class. So let me say this is a class called rectangle, and you can see inside this class, I have what we call pass. So a pass, you can specify a class with this keyword. If you you don't have anything to put in it, it will not return any error. So this is just pass. Now I have a class here called square. I have a class here cube. So what this class square is doing, you can see here I init it with length and width. And now you can see here the length, the width, right? And now what it's doing here is calculating the area. It has a method. The class square has init method, and it has instant method, right? Instant method is called area. It doesn't take anything, but it must have self. And what it's doing is multiplying length times width. We can see length times width to return the area. We have a cube. It has init method, and now it has 3 arguments. We pass the length, width, and height, and now we instantiate them. And now it return them multiplication, the cube. You can see that. Now, when we run this guy, we can see we can square the area because we are assessing for this square class. We can see, we create an object called square, passing 3 items, length and width. We create an object called cube, passing 3 items, length, width, and length, height, this. And now I want to assess this area, calculate the area. All I need to remember is just to call dot area. When I want to calculate the cube, is just to call dot cube. But one thing we should know here is that there is redundant code here, meaning you can see here I have self.length. Here I also have self.length that width, right, in these 2 classes. So what about if you are doing something in 100 classes or repeating? So to repeat code, the duplication of code is not something encouraged in Python. Then you can do this abstraction to create a class with the high parent class to hold this duplicate item, and now the child class can inherit this. This is what we do. Now, this is my class called rectangle that you see that I put it empty. And now take this stuff, this that in every class, I put them here. So this rectangle, I init it, self length width, and now I have length and width here. So we can see now we have this. Now, when I come to my square, I just init it. Remember, our class must have init and length width. But I use a keyword here, super init length width. So this means super, this line is telling this class, inherit length and width from the parent class. So you can see I don't need to do that. I just call def area. You can see self.length, self.width. Remember this length and width that we don't define them now inside my my square class, but I just use them because when this guy called the inherit, then they will be available here. And also here we can see we just super the init length the width. You can see also this inherit this stuff. So we can see like now we abstract this redundant code that repeated in here. If we want to change something here, we can just come here and change it without coming into our code to change it. So you can go to the master class. So when we run this guy, we can see it give us the same answer, 927, 927. I don't know if there is any question. So this keyword super.init length, what is actually having is telling us to inherit, anything from the super class. Remember, for us to create a child class, what we need to do is, I say square. Rectangle means inherit. This is the parent class. Remember here when we do this, okay, here, we just create a class called dog without anything here. When you just create a class, though it has something, by default object, but nevertheless. So you can see here, but when you want to do inheritance, for something to inherit something, okay, it's all right. When you want to do some inheritance, I shouldn't put this one here as well. Just leave it like this, square. There is no inheritance, meaning here there is no inheritance at all. It's just cube class, square class. I have my rectangle class. But what I want to do inheritance, this is what I do. I create a new class called rectangle, and it has the length and the width, right? Now, what I want to do is square. You can see this square. Then I open bracket and type the name of the super class or parent class. What is the name of the parent class? Rectangle. So this is what I have rectangle here. Also, this cube, I have the parent class rectangle here. So this means that it inherits the rectangle, everything from the super class. Super function is a special function that allow you to call method from the parent class. It returns an order that represents the parent class. And the name superclass comes from the convention of calling the parent class as a superclass and the child class as subclass. So these child classes are called subclasses, and this big class is called superclass. So we'll come in PyTorch saying, you will come soon saying that you must subclass some stuff. So when you hear we say subclass, you mean you need to create a child. Yeah, any question before we finish this section? Okay, there is also something that I want us to know, which is called function annotation. Function annotation is basically, when we create a function, you can see def greetings. I have a name. So now returns here, it returns basically hello plus name. But sometimes you will see something like this. What is the name of this colon? And you see like here string, and here you can see this. What is the name of this one? Who can tell me the name of this? Okay, you can see this to have something like this again. So what this is called function annotation, meaning this tells us that our name, our argument, our variable is a string, and what the function return again is a string. So this is what we call function annotation. So we'll be able to see it in the session because he used function annotation. So I put it here just to let us know. So this means that this thing is the same as this. We need to delete this. This is command, and we need to delete this. So this function, this and this are the same. But what is happening here is sometimes we may need to know like the annotation, the class, the type. So this is just annotation. So when I have this, when I run this with annotation, and now I call this function greeting and call Dunda this one, you can see it gave me the annotation telling me the name is a string and the return type is also string. So yeah, so that's basically what I want to revise. And this stuff, they are called Dunda method. Init method, they are called Dunda method in Python. Yeah, Dunda method, you may see them. Okay, so now that's revision of classes. Then we can move on to build a model where we'll be able to see this stuff that we just revised. Any question? Okay, so don't forget what we are doing. Basically, we now have our data, right? We have our data, which is we have our training data, we have our test data, everything, and we want to train the model. So let's go and try to do that. So now we have got some data. Recall some Python classes. Let's build a model to use blue dot to predict the green dot. Can we see that? Let's use the blue dot to predict the green dot. Now, if you want to use PyTorch, there are a couple of building blocks that allow you to build these models. So PyTorch has, essentials, modules that allow you to build neural networks. So we have, for example, touch.nn parameters, touch.nn module, touch optim dev forward, right? So what we do here is that we're going to use this one, touch.nn module. So which is NN module, contain all building blocks for computational graphs. So if we call here, computational graph, PyTorch. Can you see my screen? Can you see my window? Hello?
Yeah.
Okay.
Yes, we can see.
Okay, computational graph. So we all know when we are doing deep learning, what is basically happening is like, we are multiplying, these graphs and stuff like that. So PyTorch has blocks of modules that implement all this stuff. PyTorch computational, PyTorch, and then yeah. So let me just use this maybe. Anyway, so all this kind of stuff that we, build material. Oh yeah, this is a good example. So you remember we talk about, building a simple neural network that you need to have this kind of structure. You have your input here, and now they pass into some kind of layers and do multiplication. So PyTorch has a simple module that implemented all this stuff. All you need is just to call the module. So that's what we're gonna do here. So we have what we call torch.nn, contains all building blocks of computational graph. We have NN parameter, store tensor that can be used, per parameters. Remember here, we declare some parameters here. Here we have, if we remember, we have our bias, weight, and bias, right? And these are parameters. Now PyTorch has something that you can use to automatically, create these parameters. That's what I mean by that. Okay, so let's go on. Okay, yeah, torch.nn parameter, that's what you do. Let's look at it. So we want to create a linear regression. So we want to create a class. So we can see class, linear regression. This one we just name it. You can name it anyway. We just name it. You remember the name of the class, but we said that any class that you create must subclass NN module. Meaning, because I already told you, like this NN module, the base class for all neural network model, all the building block for neural network are subclasses, meaning any class that you create must be subclass of neural NN model. That is, its parent must be NN model. I don't know if I'm making sense. Remember, we understand what is parent class, right? Here.
Yeah, inheritance.
Yeah, well, inheritance. Here I said, we have class square, rectangle. Then the rectangle is what? Super class.
Yes.
This is super class.
Class.
Yes. And square is called what?
Is
Subclass.
Subclass. So what this again are saying that we can see that the rectangle superclass has a lot of parameters that are already there. All you need to is to inherit them. So what we are saying here is that this NN module, it is a base class for all neural network model. All the building block for neural network are subclasses.
Okay.
All neural network that you will build in PyTorch, they are subclasses of NN module. If you are building neural network in PyTorch, your modules should subclass NN module, and it must require forward method. It must require forward method. Look at this, what we do. Now, when I have this, you can see this is a superclass, this subclass. It has some method right here. We have method def area, right? And this also is a cube. It's a cube subclass. And this cube subclass, what it is method? What is the method of cube class?
It has volume.
Yes, exactly.
Volume.
Yes, exactly. It has a volume method. Now let's go back and understand this English. The base class for all neural network modules, all the building blocks for neural network are subclasses. If you are building a neural network in PyTorch, your model should subclass NN model. and require a forward method be implemented. And it must have forward method. So this is what I want to tell you. We can see it have this, in it, and it must have a forward method. Can we see?
So doctor, this forward is more of like interface.
Yes. So this forward
in
is
Java.
what will do the calculation for the model. So remember, this is okay. Let me bring this forward. Yeah, let me bring this. Try to understand that. If you don't understand, this is very important. We should spend our time here trying to understand it. So here, this is where we do training. After we prepare our data, we do training, right? And in training neural network, there is what is called forward pass. So let me go here. Forward pass, forward. So in neural network, because here we are not doing, we are not doing the theory. So in neural network, we have what is called forward pass. We have what we call backward pass. I want to get a good forward. Okay, anyway. So what we mean by forward here, you can see, we are moving from here to here to make a prediction. So a forward pass basically make a prediction. That is it. And backward pass, try to change the weight if you have some kind of mistakes or the prediction is not correct. Then we have what we call backward pass to correct those weight. This is something that implemented by what we call backpropagation algorithm. So let's talk forward pass, and then let me use this. Yeah, you can see this is what we call forward pass. Like you have your input, you do prediction to get this. So in essence, when I said forward pass, in essence, I mean making prediction. That is it. In essence.
Is it not the same as like feed forward?
Yeah, this is the same, like feed forward is architecture, but when we say even the feed forward, we do back propagation. But when we say forward pass, when we say forward pass, I mean we are trying to make prediction. Backward pass is, when here these are the futures and you make prediction, and this is not the correct prediction, you iterate, go back, and update the weight and parameters. Maybe I can explain this later with some image that I have, but I don't have them now in one book. They are very useful to understand this concept. But anyway, let's go on. So what I mean by making forward pass is to make prediction. So here we can see, let me go this one by one. So here I create a class called linear regression, and I subclass this linear regression from NN module. And now you can see I have init method for this linear regression. But this init method, this class, so we use superclass to inherit everything from the NN module, which I already showed using superclass. Now we have, NN parameters. So for you to define parameters, we use NN parameters. You can see we check touch.rand. Remember, we, touch.rand create a random number. So we have 1, and we have what is called required grad true. We have data type is float. Now, this is something we need to know. Here, this is weight, this is bias. If you remember here at the below, in the previous sessions, we just say weight is equals to, weight is equals to 0.1 and bias is equals to 0.3. Now, when you are training a deep neural network, what you do is you initialize weight and bias. When you initialize them, you make forward pass. When you make forward pass, you make prediction, then you will see that your prediction is not correct. Like it's not even near the correct. Then you go back and learn, okay, this weight is 0.2. I get wrong correction. Okay, maybe I will go to another direction, 0.1, so that the prediction will be accurate. And now update also the B, maybe to 0.4. Now you make another forward pass. Your prediction will now, if the prediction, for example, if the accuracy, if the prediction is the accuracy is 0.1, and you make some kind of bad prediction, when you update this one, your accuracy will, increase. Now, what we do basically, you keep iterating, changing this weight until you have a good prediction. I don't know if this is understand. It's difficult to understand if, one does not have the theory behind this back propagation, what is happening behind the loop. Yeah. Okay. So I will explain this more in detail, but what we need to understand right now is this. We need to subclass NN module to initialize weight and bias. That is it, initialize weight and bias. Now, when we initialize weight and bias, then we need to do forward pass. The forward pass is basically, or we already know, is y equals mx plus b. That is to make prediction, because you remember, we already have our x, which is the futures, right? And we have bias and weight, which is wx, which we declare the w here is weight, the bias is here, w is this, and we have x our futures, remember it. So we are multiplying here, self dot weight times x. Remember what is our x already? Our x, remember our x. Oh, I'm creating something different here. So remember our x, then we have our bias. So here, this is how we get our weight. We say self dot weight, because remember, any variable that we declare inside this init must start with self, right? Self dot weight equals to, how do you assign parameters? All these weights and bias are called parameters. Now you can access parameters through nn dot parameter, So nn dot parameter, how do we initiate the weight? We want it to be like a random number, give us a random single number. We already know what is touch.rand, right? Touch.rand, create a random number. We put it 1, but we also need what is called required grad. This allows us to use what we call gradient descent to determine how do we going to change the weight. Because if we make a prediction 0.1, if we make prediction it's not correct, we need to come back and update weight and bias. But how do we update, know which direction? How do we know informed decision, like the way we update weight? This is will be taken care of what we call gradient descent. And now here, remember, we float just to tell what our data type random number is. So this is how we initialize the weight, and this is how we initialize our bias. We said this is one number, and we required grad equals to true, and now this is it. And now we have our this thing, and now we have the forward pass. So forward pass define the computation in the model. That is what do the model computation. So here we can see forward, self, remember self is necessary in method. And now we have x. So x is the future we give to the model. But here you remember this is function annotation that I already showed you. This is telling us that x is a touch tensor, and the return it will give a touch tensor. But you can delete this one. This is just explanation, as we already know what the meaning of function annotation, and it returns self dot weight times x plus b does y. So this is basically our, what do I have?
There is info column.
Where?
There is info column.
Okay. Okay. So this is this is what will calculate our stuff. So if above sounds complex, things of like this, almost everything in Python here comes from touch.nn. So here they explain everything here as well. NN.module contains the larger building block, which I already explained, this NN module. NN parameter contain the smaller parameters like weight and bias. Put this together to make NN modules. So you can see this one. This is how we initialize the model parameters. And we need to set required grad equals to true, because that's how the weight will know which way, how can I update the weight so that I can make better decision. And we have forward pass, tells the larger block how to make calculations. So this forward pass is the one that tells how to do the calculations, which we say it's here, weight times x plus bias, and touch.optim. Here we don't have the optim, we'll come to it later, which is define some of optimizers. Okay,
Doctor,
Yes. Yes, Shamsuddin, go on.
Doctor,
Yes, Shamsuddin.
no, Salisu.
Okay, Salisu, go on.
Wannan forward thing,
Hey.
wani function da model ɗinka zai yi, a nan za ka implement nashi kenan, calculations
Exactly.
da ake.
Yawa, duk wani calculation da model ɗinka zai yi, yanda zai calculating ɗin prediction ɗin a nan yake. A nan shi kawai wannan init ɗin you initialize your parameters ne shi a nan wajen kawai. Amma duk wani abu calculation ɗinka da za ka yi a forward ɗin nan yake.
Okay.
Yeah, everything is inside this forward. We'll see a lot of them. Just this is an introduction, and you can go through them and and nail them. So now we can see we clear our class, linear regression model, linear regression model. So what we need to do, is to go further. And now, so we already create our class, which is linear regression. So we can see we create an object now. So here you can see I set some kind of seed, and now I say linear regression model 0. Remember here, this is how we create an object, right? Which I already showed. If you already have an existing class, if I have a class here, square, and now for me to create something is say square, I call the class here. And now because I have, input here, length and width, that's why I have this 3. So this is how you create like the object. So this, when we create our linear regression class, so we initiate on object, create an instance of the model. So here we create an instance. So when we create an instance here, we can even look at the parameters. So here we can see, we can check the parameter of the model. We have model.0, we can say dot parameters, right? Dot parameters. Remember, this is just creating the object here. We create the object and we can check the parameters here. But here give us, generator, but I can use the list here to give me the parameters. So you can see the parameters it contains. We have, the first one and the second one. But you can also use this, static and to show you the parameters. So you have weight, which is this. The bias is this. You can see here, we initialize weight and bias. Only a single one number, random number. So it initialize them here. These are them. Your weight and bias. And this weight or bias, these are things that we learn when we train a deep neural network, because we learn them at the end when we train a model. And now you can even use the keys to see the two things you have, weight and bias. Any question? Yeah, so just to recap, the main concept is here. This is the main concept, creating a class. That is why I take time to revise the class. We, we have a class, this linear regression, you can name it, but it must subclass NN module. And now you need to initialize your weights, your parameters. And you can see we have init self and this super init, it means this is, a subclass of, and here we have NN parameters, we define parameters weight, and we define parameters bias. And now we must have forward, and the forward is where you must, for forward, because in forward, remember when you want to do forward, you must input your data. Can you see the data? Answer, you must input your data to the model. Can you see data must come into the model to do training? So here we want to do the training in forward. That is where we do training. So we must give the data. Can you see X is the data? So you can see here now we do the training like, calculation. So here we say self.weight times X plus this. So this section is what does the training. Okay, now here we can see that we create a model. We create an instance and we see our parameters. Now let's look at how we can make predictions. So for you to make predictions now, what we can do basically is, use what you call, with touch.inference mode. We want to make prediction inference. So touch.inference mode, and now model. You remember this is my model that I created, right? I created my model from linear regression. Pre-linear regression, you can see I create an instant or object model, which every parameters for the model is now inside this model zero that I created. Every parameter, the model, because I create an object here, Can you see that? And now it's inside here. Remember, so everything here can, this object is now inside here, even the parameters, everything. So we can see when I want to make an inference, I can say with touch.inference model, I input the text set. Remember, I trained the data. I input the test set, which is X test. S test. Remember, this is our S test. Here it means we have done training. Looking at this section here, can we see this forward pass? It means we have done training. It's a training step. It's a training, it's something like training. And you can see when I initialize this linear regression, when I initialize this, it means, you know, I'm calling everything now with this. Now, when I call this, I want to do this touch.inference. Can we see that? Model X test, give me predictions. So here I'm making an inference. Previously in older version of PyTorch, you will see we are using what we call with touch.nograd. Touch.nograd, if you are familiar with Python, previously they're using touch.nograd, but this one is now beta. Now, when we create this, we have done an inference now in our YPRED. This is just an example of what this is. This is called Context Manager. It switch up like a lot of other things like gradient and whatsoever. Yep. So now we have done training. Now we can see our value. So we can see, you know, the predicted values, which is YPRED. We can see the predicted value. These are the predicted values. These are the predicted values, which are the tensors. If you don't understand, we'll, you know, this is just introduction. We'll make more clear about it. So this is our, you know, prediction value, and we can predict, you know, plot the prediction. When we plot the prediction, look at what happened. So you can see now this is our prediction. This point we predicted here. 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 So you can see the prediction is not good, right? Remember, we want to use this blue line to predict this green line, but this is the prediction, right? It means, you know, our prediction is not good. We need to, you know, retrain the model, optimize the model to make it better to fit the data. Right, any question? Okay, so I think we will stop here. Next week, we'll be able to go back. I will share this. You go through it, and we'll go back a bit to it so that we can see how can we improve this prediction so that it can predict, has a better predictions. Yeah, and yeah, you need to just go through it, and you know, when we come next week, you you know, have the clear understanding of what we do. All right. Any question again? Shamsuddin, ka gane kuwa?
Doctor, na gane sosai.
Yeah. Okay. Any question? All right. Yeah, the most important part is one needs to understand, like, you know, anyone who is questioning on here, question. If you have question, ask question here.
Nan abin nan da ake inheriting.
Yes, you see, kace me?
Class that inheriting from n.module. Well?
Yes.
It comes with some method like the forward method.
Yes.
So when I'm overwriting one methods in Echo, we use them as we inherit them.
There are a lot of other things that are implemented in NN module that we don't see them. They are the power hosts that are doing everything here. So all you need is just to implement your own function. So if we go here, let me see. NN module, PyTorch. So you see, like in PyTorch, this is the website of PyTorch. You can see Torch NN. Inside NN, there is modules. So you can see all these ones are modules that I was talking about that we, call. You can see them, all these one, they are modules. We have module the PY. You can see them a lot here. So they implemented a lot of things that abstract you building neural network. All you need is just to call them, you can see a lot of activation function, the function, batch norm, dropout, platinum for linear module, all this stuff, pooling layer. So all these, they are ingredients that can allow you to build neural network without, knowing the, details about implementation. So all we need is just to have, specify your method, what you want to do. Yeah. Any questions?